morning, I'm Addison Snow with Intersect 360 Research. We are analysts in the high-performance computing industry, which means we do the things that analysts do: market sizing, forecasting, trend analysis, spending analysis, end-user surveys, write white papers, et cetera, et cetera. And of course, a major theme of our research over the last 2 years has included not only HPC Cloud, which was the theme of the previous 2 days of the conference before we started ISC Big Data, but Big Data, of course, and I've loved the theme of this conference in terms of where HPC is beginning to collide with enterprise. And I have the pleasure of moderating the vendor panel for both conferences. Some of our Big Data sponsor vendors are stepping up here. I am, in this case, going to start with a very brief 5-minute presentation on an overview of some of the research that we've recently completed in this space, and that will help set the context for some of the vendors' comments going forward. This is based on new survey data that we have coming in. This is the second year that we've done such a survey on big data from an end-user perspective. And very importantly, we're using not only our traditional HPC database for this research, but partnering with another analyst, Dan Olds of Gabriel Consulting, contributing 100 what we'll call business or non-HPC enterprise respondents into the data set, because part of the analysis is to do a compare and contrast of the similarities and differences of those types of end users when they're evaluating their big data problems, the barriers, the technologies they deploy, where they are and aren't satisfied. This is now very fresh data on the most recent one. I've myself been in possession of it for approximately 3 weeks now. So we've dived in for some of the very early analysis. The reason it's important and why we even have technical computing or HPC analysts to begin with is that there, of course, has traditionally been a very different mindset between HPC and enterprise computing, where because you're solving a discrete problem and you're trying to bring computing to bear on the technical computing side, whether it's to design a new minivan or find oil or fold a protein or spy on people or whatever it is that you're doing, you tend to have metrics of price performance that drive your acquisitions and a relatively higher rate of the adoption of new technologies, new approaches, new algorithms, whereas enterprise computing, this is more about keeping your business running. Toyota buys many computers for many different things. When they're designing new cars, trucks, and minivans, it's HPC. When they're serving up their web page, delivering email, running their payroll database, their ERP system, that's enterprise computing, keeping the business running. And there, your dominant purchase criteria year after year tends to be reliability. It doesn't do me a whole lot of good to serve up an email 8% faster if it's going to crash now and again. I really just want it to run the same. So on the left side, you have once you solve the problem, it's no longer interesting. You move on to the next harder problem. And on the right side, you have once you solve the problem, for heaven's sakes, please don't touch it ever again. Just let it run. And the reason this is important is because big data is now an enterprise IT kind of application, but it carries more of an HPC mindset in terms of it's a discrete problem that needs to be solved. It's not about just the everyday running of the business, but rather striving for some sort of competitive advantage, which makes it more like technical computing in that respect. Insight number one from the study is it is a huge opportunity in terms of our clients who are the HPC technology vendors and where they might sell their solutions in new areas, whether or not they think of them as HPC. Mark Torr drove to this directly with regards to his presentation right before mine. There's a great deal of money being spent on this today. Now, this is, of course, subject to sample bias. People who don't have big data problems tend not to answer this particular survey. So that takes care of a lot of people who would consider themselves in the none column. But once people identified as having a big data problem, 60% of them are spending more than 10% of the IT budget on that problem. Not 10% of your HPC budget, not 10% of your storage budget. The curve here is around 25% at the peak, 25% of my IT budget related to big data in 2012. Now that said, we tend to use caution in describing the size of the so-called big data market. If you went out and said the big data market is however many billions of dollars and growing at 11% to some impressive number by the end of the forecast period, you need to be careful about what specifically are you counting, right? What is one big data and how much does it cost? And it brings up the question of how much of this is new spending relative to all of IT, and that's something that we also track. But I think this is a good way to look at what's the actual opportunity. So you can say the size of the big data market, but it has to be how big or small you care to draw that circle. The second major insight, and this also came out in this morning's presentations and yesterday, it really pleased me, is that this is not just a Hadoop thing. In 2012, only 17% of respondents used the word Hadoop when they described their big data applications. Tell me what you're running for big data. Hadoop comes up 17% of the time. I got the new data set and I immediately went to see how much Hadoop has gone up over the last 18 months to find that it's gone down. And it's gone down particularly among the enterprise types of respondents. Academics or government were much more likely to use the word Hadoop. Now this isn't to say that commercial enterprises aren't using Hadoop. Of course they are in many cases, but as a framework or building block, and where we do see a lot of solutions coming out is that these applications, when end users describe them, tend to be dominated by in-house applications and algorithms. And that's really what they're trying to enable. Now, the reason this is important is when we guide our clients on describing their solutions, if the first word out of your mouth is Hadoop, it can unnecessarily restrict your audience in terms of who's listening to you. And another way to think of it is this way. The message, how can we help you scale your internal applications and algorithms, has about 4 times the resonance of, here's how we can help you with Hadoop, right? And there's relatively little discussion around how we can help you build those applications up. Finally, and the reason this is so important with regards to the overlap with HPC is that performance really matters. We do these satisfaction gap scores of how important on a scale of 1 to 5 are all of these things when you're evaluating a new storage or compute or interconnect or cloud technology. And that's interesting to see what comes up as important. But then also ask how satisfied are you with the same impressively long list of things. And that's independently interesting. But where the real market movement tends to happen is in what we call the satisfaction gap of areas that have relatively high importance but low satisfaction. It's not enough to say it's important. If I'm also satisfied, then, well, great, I'm not going to do anything new. If I'm not satisfied but it's not important, then it's not worth the pain to switch. But this is where we start getting into these areas of relatively high importance and lower satisfaction. And the interesting thing is that across both years, not only did metrics of I/O scalability and performance come up number 1 overall, it was the same in both the technical set and the enterprise set. In terms of a metric of scalability and performance, this is for storage in particular here, outperforming, or I should say outgapping, metrics of reliability or storage capacity, which is counter to the way that enterprise computing would have normally approached the market. Now that's as far as I'm going to go into this study for 2 reasons. One is because the full presentation would take about 8 hours, not kidding. And secondly, because you haven't paid for it, and there's that practical consideration. I have given a 45-minute version of this same presentation just recently as the keynote for the Storage Developer Conference and Analytics and Big Data Summit through SNIA. There's a link here to the video. If you don't want to scribble down that bit.ly link, I will post it immediately after this on my Twitter feed at Addison Snell, so you can grab it from there, or you can email me to get it. For really the whole presentation of all of the data, if you're on the technology vendor side, please call me. I'll be delighted to sell it to you for very reasonable prices. The end user side, it's actually easier than that. If you sign up for our HPC 500 user group and agree to answer surveys from time to time, we will share our research with you. This is how we increase our footprint to the HPC community. I now have the pleasure of moderating the Big Data panel where our vendors can talk about their solutions against this market context and some of the things that we've been discussing so far. Unfortunately, Stefan Sig from SAP.
Update.
Sorry?
So apparently somebody will replace Stefan who misunderstood the requirement.
Who is replacing him? I have a chair right here.
Right, so bear with us for...
Anyone who would like to come up and represent SAP, we have a microphone available for SAP. Other than that, Thomas Kyles representing SAS, Bernard During from Intel, Stefan Weidner from SGI, and Frank Harold from Quantum. And I'd like to start out just from an introductory perspective, letting each of the vendors, this is not advancing now. Did I lose this? Panel question number one.
Okay,
Just
before we do that, can we just take the SAP arrival?
wonderful. Enter and sign in, please. You state your name for the panel, please.
Okay, my name is Ingo Brenkmann. I'm here on behalf of Stefan Zick. I'm the product manager looking after SAP HANA on a global basis.
Thank you very much for joining us. I'm sorry, it was Ingo?
Ingo.
Ingo. Thank you for joining us, and since you've got the mic, I'll let you go ahead and start off. In the context, as we've just been discussing it, can you briefly describe your company's view of big data? Of course, that has a lot of different dimensions to it, and we've been hearing about the different types of problems. Something I tweeted yesterday was that something we found in our research is that it's very hazardous to assume up front, to presume to know what the end user's problem is to begin with, let alone what the solution is. So how is SAP viewing big data in general and designing solutions to these problems?
Okay, thanks for giving me 10 seconds to think about it.
Would you prefer to go fifth? I can start down here.
No, perfectly fine, because I mean, this is something we're spending a lot of time with. So to give you an idea of how we see big data, with the introduction of the in-memory technology, we've actually had the ability to go from an aggregate point of view on information to a very detailed one. So we now have the technology at hand that allows us to look into very granular data and understand what's in that granular data. So instead of looking at very highly aggregated information, we can basically give up on the causality we've applied to data in the past. So in the past, we've taken the causality from business, the understanding how business is organized, and tried to optimize the data in a way that you could handle it, that you could work with it. However, every time when you apply a model, there are assumptions in there. And if these assumptions are wrong, the model may be interesting, but it's completely pointless. So what we can do with the in-memory technology is, instead of applying causality in order to get the speed and the ability to understand the data, we can now go into that and apply statistics. So we can look at correlations, we can look at unstructured data or semi-structured data. I think the term is much better than unstructured, because also text is structured by its grammar. We can take this technology to analyze all the data on a very granular basis and understand what correlations are in that data. And from that, gain deeper insights, because what we're seeing is that there are signals hidden in all the big data that companies are really interested in finding out. So that's what we're doing. We have projects running there. We have, for example, a case where we're collecting data from the tires of cars. That's a project we're running with Pirelli, to gain insights into logistics, to gain insights into, to understand the dependencies in all the data. And we also have a very interesting project together with eBay, where we are collecting signals out of this vast amount of data without trying to pre-understand the business, but to figure out which signal is there in the data. And that's, I think, what we're adding with the big data topic to the SAP product stack.
Yeah, you know, Stefan, you made an excellent point there that I'm delighted came up so soon. I usually hope it'll show up by the end of an hour, which is that all of the analytics in the world won't help you if your analyst is writing bad algorithms. So you can ask the wrong questions about the data and come up with some really poor conclusions, and the technology won't help you. But another thing you said there about in-memory analytics, are you making any assumptions about what type of data you're dealing with, or where it comes from in providing these solutions?
Yeah, I mean, we're working closely together with Intel here, integrating the Hadoop distribution from Intel to deal with huge amounts of data, so when you're in the petabyte range. But the analysis and the insight we consider as being kind of time critical. So especially when you think about detecting signal, it may be very important to react on that signal before your opportunity is gone. So,
the different dimensions of how you ingest a 150 petabyte amount of information is very different from managing 150 million separate inodes or having the time factor of the data, the concurrent users accessing the data are all different dimensions. As you mentioned, Intel's distribution, what I most liked about that chart was that in your Hadoop distribution package, only a small portion of it was actually Hadoop, and then there was a lot of other stuff around that. So Bernard, maybe you would like to take on this question next.
Yeah, thank you, Edison. And so, you know, Intel, of course, as a technology provider, lots of CPU power, SSD, so we're, you know, network connectors, we're building all of those technologies, and we're also doing software, as Girish pointed out. We have lots of software solutions, and one of them that we've added to the portfolio and gone public with this year, we've been using it internally for many years, is the Apache Hadoop, and we officially continue to further develop that Hadoop software, give those developments back to the open source community, and make the open source product better and faster. And what we do is optimize for the CPUs and for the storage devices. And Intel is certainly a horizontal technology provider of hardware and software to underpin the analytics and the applications, the in-memory applications running in HANA, for example. So my view is, you know, big data is for very, very, very large poly-structured data. The big lake, as Girish called it yesterday. And then we have specific applications like the HANA, which are running in memory, but they're constrained by that. So that the data set size is limited by whatever memory I can put on my servers. And in the Intel Apache Hadoop, I can keep all of the history. I can keep atomic level, no summaries, no cubes, and I can query 7 years worth of data or 10 years worth of data. So I think that's what we just want to provide the underpinnings, and it's going to be open for all analytic software on the planet.
Right now, as luck would have it, my panel organized from right to left kind of sets up to look at different dimensions of this technology. Frank, as you're coming from quantum, you're probably well established to think about some of the massive storage of data and how things like hierarchical storage management or tiered storage or archiving, and there we use the term data warehousing as part of the overall solution. I'll come into it. What's your view on this?
I mean, you have mentioned pieces of, so I would differentiate big data in the analytical part and in the infrastructure part. And as you have mentioned already, quantum is very much focused on the infrastructure part with ingesting the data, with processing the data on a storage platform, as well as preserving the data. And preserving is one of the key elements. If you have created your data once, they cost a lot of money to develop. And our mission is to keep this data alive, to keep this data maybe forever, to rerun tests, to rerun with new application layers which are coming out maybe in 5 years, in 10 years, to get one step further on where we are today with all the developments in big data. Basically, that's it.
I actually wind up disappointed sometimes that we don't hear more about tape and its role in these types of solutions. It's almost like people are afraid to talk about it, but when we get to the larger types of end users in our surveys, most of them have tape as part of their overall solution. And the reason they do is because it offers more bytes per dollar, more bytes per watt, and more bytes per floor tile than spinning disk, and the data lasts about 3 times longer before you get media degradation.
I mean, question in the audience, who is using tape actively today? Nobody. Okay.
Quite a few.
Quite a few.
They just don't want to admit it.
I would think a few ones also tired from yesterday. I mean, tape is not sexy. It's long term in the industry.
I kind of think it is, but that's
I mean, it's very, very traditional technology, but it's still alive, it is still going on. If you're seeing in the market, there are still developments going on with newer technologies. We're talking about LTO6, LTO7 is on the horizon. Oracle just announced a new generation of T10K drives. So there is still a lot of pressure and feedback from the market that this technology is still in use and actively in use. Otherwise, no vendor would start investments in this technology. The other point is, and that is a little contrary to tape, is with the object store coming up, it gives some alternatives to tape, may not in the high massive amounts of data, but if we talk about the mid-tier level on the amount of data, object store is getting more and more hot in the industry, where more and more customers are looking into as an alternative to tape.
All right, I have to get through some of these introductions here, give our other panelists a chance. Now, Stefan, SGI is coming from yet another perspective because you can handle some of these very large in-memory things. You've got scalable storage solutions. Take your shot at just an overall view of big data and providing solutions for certain categories of big data problems.
Yes, I do. Thank you very much. SGI has a very differentiated view on big data because our history comes from the technical computing part. So as business is getting more and more interested into big data solutions, we have to provide more and more contact and solutions into business interests. So everybody who knows Hitchhiker Through the Galaxy knows the answer, 42. The slogan of SGI is finding answers. So we can help to find you your answer extremely fast with extremely modern and up-to-date systems, but we're not responsible for the question you're asking. What we can provide for the big data opportunity and the work there is to help you set up a system that matches your needs, that matches actual performance needs, technology infrastructure needs you have in your data center, and to help you set it up, get the right software in place to get the work done, to get your problem fixed or get your answer, and of course to help you serve the system afterwards, set up and to run it. And this is one of the aspects with the experience SGI brings with it from the compute perspective, from out the HPC business, that is very, very rare in the vendor circle.
Very good. Now, Thomas, you've been very patient waiting down here at the end, but I made you wait because Mark already entertained us with an excellent presentation looking at the analytics side. You're not on the hardware side, but I love the perspective about the intersection of HPC and enterprise with big data. Why don't you go ahead and provide an introductory summary there?
The difference between Mark and me is I don't hate big data because I am from a marketing perspective. And with the term big data, everyone got the impression there is a big need for analytics out there. This is the major move we feel out there. And this analytics business is the core business of SaaS from the very beginning. So the market somehow comes to us. This is an impression we feel, and we feel that we have to deliver a bunch of technologies, not only one. It's not only about the memory, but as the other panelists already stated, there are several aspects of big data to be aware of, and we see the data management issues, data quality, complex event stream processing, all these types of technologies which were available in the HPC community are now fitting into real life use cases in the enterprise world, and this is where we are working on and where we have projects all over the world.
I don't hate the term big data either, and not least because it gives me an opportunity to sell some research. But in particular, when we hear supercomputing labs will say, well, we've been doing things like this for years. And I think that is true, but underappreciates the notion that we have been at an elbow in the rate at which data is created and accessed in more ways by more types of organizations. And there are new types of applications that are being brought to bear in these areas. Now, on the other hand, you can have some 25-year-old with his big data startup who insists that all of this is new and we've never seen it before, and that overcooks it in the other direction. I think it's very important to realize that there exist technologies that have been nascent in the HPC space that have applicability to big data, and that's exactly what we're talking about here. I'm not going to be a slave to the order that these are in, but I do like the next question as it sets up with regards to this, which is directly to the point. Obviously, Hadoop is the big new word that gets associated, sometimes well and sometimes not so well. I think sometimes people get the impression of, gosh, I have a lot of data, that must mean I need to buy a jar of that Hadoop stuff and rub it on my data warehouse, and then the problem will be solved. I hope I don't run out and have to buy another jar, right? So the question is, how pervasive is Hadoop in providing real big data solutions, and where do you see Hadoop as being appropriate or inappropriate? And I'm going to actually start down here again, because I think Mark started to touch on this a little bit. Go ahead, Thomas.
Indeed, Hadoop is a topic for us. We developed access engines to Hadoop. We developed the in-memory, in Hadoop analytics capabilities for SaaS, since some customers are asking for. On the other hand, we have made projects which failed with Hadoop. We put our infrastructure on a Hadoop basis and our SaaS above, and there were several things which were not really reliable and feasible for the enterprise users. They don't want to be the first to detect a bug in Hadoop and to fix it, which is common to the Hadoop community, and okay, we have a new feature found after fixing this bug. This is not how an enterprise wants to work. They want to have solid solutions running out of the box and don't care about the details. And therefore, in this particular case, I have a project in mind with a big telco company. They skipped the cheaper infrastructure solution, Hadoop, for a more cost-intensive but well-experienced and well-equipped and well with services capabilities equipped solution by a big MPP database vendor, which was much more expensive at the beginning, but in the overall costs it was better at the end. So it is something new. We are aware of it and we support it, but it's not the game changer that is.
Now, Bernard, I know you have a Hadoop solution, and you look like you're ready to jump at the mic there, so I'll go to you next before you hit me with the microphone.
Yeah, thank you. First of all, pervasive, it is not that pervasive yet. And secondly, the skills are lacking in the organizations to do it. That's clear. And thirdly, though, Intel does have a stable Hadoop release. And I think that's one of the differences we use it internally. We have hundreds of people using the Hadoop release internally, but we proved it there first. Then we proved it with the biggest telcos on the planet in China, and we got it scalable. And that one is available. SAS has tested it now and needs to certify it, so that's something to do for them from our. I think there are bugs in it, and that's part of our job, is fixing those bugs, and that's what we're doing day and night. We have developers working on that, making Hadoop better and enterprise ready.
Yeah, enterprises can be mistrustful just of things that are open source in general, and I think there is the effect of Intel branding and marketing it gives it a certain enterprise cachet. You've done this with Hadoop as well as things like Lustre, try to make it less scary in terms of bringing a more HPC or open source technology into the enterprise. Stefan, your views on Hadoop here.
Okay, first of all, there is a certain characteristic to Hadoop which is related to volume and price. So if you have data that is organized in some form of a key value format, Hadoop has got a scale when it comes to price per terabyte that is unbeatable by any other technology. So if you really have volumes of data to hold, Hadoop is kind of a very good choice. However, it's expensive to get the data out again. So while it's a very good trick to store a lot of data in Hadoop, writing the MapReduce algorithms and making sense of the data may become really expensive because you need experts, because you need people who are capable of doing that. And that market is very small, so there are only a few that can really deliver valuable solutions. So at the moment, what we see is that typically large customers who have, for example, clickstream data, a huge volume of data, would go for Hadoop because they potentially have people who can deal with that. What we're trying to do here together with Intel is actually making that more accessible. So making Hadoop a component of your infrastructure so that while you're keeping hot and important data that is in memory where you do immediate calculations, you can call out to a Hadoop store that holds huge volumes of data, so petabytes of data, where you have some form of interaction with that, because typically the analysis of data in Hadoop is run in a batch process, and then we take insights and we combine that with information in memory and give people the possibility to navigate. So what we're really looking at is making, seeing Hadoop as a component of your infrastructure and making it useful, bring it in the context of your enterprise data.
I called you Stefan, I
Yeah.
apologize.
No problem.
It's the sign in front of me that's throwing it off.
I'm the light stand-in for Stefan.
I might do that again by the end of the panel, I apologize.
No problem.
Now, you did say dollars per terabyte, you talked about petabytes, those were words that I last used when I was talking to Frank. Do you want to take a shot at this question here?
I mean, we have started with if tape is still valuable media. We are talking about storage tiering. So, I mean, in the Hadoop world, what we are trying to do is to interface with the Hadoop world and get data offloaded, get data tiered into storage models, so that we don't need all the data all the time on spinning disk. So we are getting data into tiering models, which gives you a choice on selecting which data are hot, which are actively used, and which data we might offload in some different storage tiers you can get back, and which are safe and secure.
Stefan, you're now the only actual Stefan up here, so I'll say, Stefan, point to you this time. Go ahead.
Well, we have several Hadoop implementations out there, and customers using it actively and are very, very happy with it when the workload matches the tool. Not everybody has the problem to use Hadoop as a solution. We see two positions where Hadoop becomes extremely inappropriate in usage. One already mentioned by Frank. We have several large Hadoop implementations out there that are mainly used as a storage platform. Storing data, collecting data, not using the full power of computing them, but storing them for later. And this is absolutely inappropriate because there are more efficient and cheaper and more intelligent storage solutions that have a large-scale possibility meanwhile. Hadoop is not the only one.
Are you thinking about parallel file system-based implementations in particular?
Parallel file system may be one approach. Object-based storage system may another
sure.
one, etc., etc. There are several out there. We are serving all of them because they have their very special needs in the market, and depending on what you want to integrate, it's the one is better than the other.
And you were about to say a second category of solution.
The second category is if the customer is experienced in developing Hadoop, he will do it. But most of them are not. The most applications in the market are self-written. The customer is used to code his own stuff, but not always he's able to put it on Hadoop or in cluster environments. And that's the point where we often say, think about a shared memory system which behaves like one single big box. You can put your problem in and you get your result out extremely fast. This may be a setup for a database solution like SAP HANA or others. This may be a platform for self-written applications of any kind. As long as it's running on a Linux platform, it may work.
I liked the point of object-based storage, which is one of the technology areas where we did see a significant difference between the technical data set and the enterprise data set. We really don't find very much object-based storage in non-HPC enterprise right now. It's really much more common in HPC. It might be one of these areas that moves forward. I want to ask quickly another question. Given these different types of solutions, where do you think we are now in hype versus reality on big data? This is a little more conversational. Anyone who wants to get in on this one can just grab the mic.
I have a short answer. I think it's just in the early adopter phase for the Hadoop.
Early adopter phase.
I think actually in Europe we have a little bit of a problem with big data. So it's been kind of, excuse the word, but it's been, it's this BS word now. So
We heard that word yesterday.
I think that has had an impact on the way people were looking at it. And we're actually in Europe behind compared to the US in the adoption of the technology, and I think that's a disadvantage. So we should consider the use cases of big data and how that really helps drive business cases, and then look at how we can leverage that and start going. So I think there are areas where we are already, where people have a lot of experience, we're moving with big data, but there are other areas where we're just early adopters, where we're just in the beginning phase. And I think the technology has a huge potential, and we should really think about what's the essence of it. So what is in big data for my company? How could I leverage, for example, huge information pools and enrich my application or my business with it?
Yeah, I take your point about Europe being slightly behind. My personal view on it would be it's related to the fact that spending in IT in Europe or HPC in Europe has been flat the last couple of years, primarily due to the Eurozone crisis, and the other regions are growing a little faster, which gives you a little more latitude in terms of adopting new programs or new technologies. Thomas, you were grabbing the mic. Go ahead.
Yeah, I totally agree that it's all about the use cases for the enterprises, and this is slowly but surely getting its way. And there's more and more enterprises get used to not know what they can really do with it. The problem in Germany is this privacy issue connected with big data and Facebook and social media. So big data is really connected in the public opinion with those Facebook and personalized information stuff. And this is a huge challenge for the vendors, for us to educate the market. It's not only all about having the NSA spying your email or stuff like this. It's about machine sensors, Pirelli, or what other projects are around. This is maybe at the hype, but it's slowly but surely beginning to mature.
It's not spying, they're doing it completely overtly. If someone watches you without hiding, it's not really spying.
Okay.
That actually builds directly to my last question in this section, which is you're talking about the use cases, and we were just pointing out that the majority of these are built up from in-house applications, algorithms. There's a lot of roll your own. We haven't seen a whole lot of standardized solutions yet in terms of dominating killer apps that start to take over the market. Is this a good thing? Is this the way it should be because they're individualized problems? Or are there specific tools that ought to be more common across these organizations? Nobody. Stefan, go ahead.
Well, from our point of view, we're one of the most flexible vendors in there. So from our point of view, it's very good when the organization is responsible for their own code, because that's their intellectual property and that's their benefit they can provide to the market. When I take a look on our car manufacturers and our customers, they're collecting extremely amount of data, or they just start to do. We have several of them. So we see one manufacturing already collecting terabytes of data per month about the cars running out. During the owner of the car is driving it somewhere in the world, the manufacturer collects how the car is used, who is using it, when it's used, where it's used, what are the failures stepping up in the system, what is the car behaving like in the market.
Are you arguing then that should be an individualized solution? It's not going to be a cookie cutter approach?
That must be an individual solution, because I cannot imagine that a corporation like this will share its most private data about the usage of their customer, even only with an application platform with its competitors. So this
Go ahead.
And as long as they're using their own algorithms and programming effort, we have the opportunity to provide them with all the tools they need. If it's standardized, it's getting forced into the fence. We see it more beneficial for the market when it's open.
It's one vote for individualization, which has been a hallmark, by the way, of certain HPC vertical markets all along. Oil and gas, finance, notorious for driving the majority of their workflow on in-house applications and algorithms. Other views that are concurring or disagreeing?
Well, I think what Intel's trying to do is certainly standardize some things, like security, so they're standardizing the encryption so that that is available for everybody. We're writing a new SQL interface to Hadoop so that everybody can put their SQL BI tools on top of Hadoop. So those are things to help, you know, and I'll say, with Hadoop moving to the enterprise. The analytics applications, you know, they have to come from SAS and SAP and other companies.
Thomas?
Yeah, I agree. There has to be a kind of mixture. You need the individual programming models to build your broad intellectual property into solutions. But we learned yesterday from British Telecom, at the end of the day, use of data has the need of users. You need the users to make use of it. And how do you reach more users? With standardized tools, which they are able to use, where the data is already there. We can visually interact with it, stuff like this. So there has to be a double approach. For sure, you need your own models, your own programming capabilities. But if you really want to attract more users from the business departments, it has to be standardized.
Very good. I run panels. I'd like them to be as interactive as possible and conversational. So I'll take a break here between major content sections, see if someone in the audience has a question. Otherwise, I'm quite capable of moving on. I'm going to give this about 3 seconds, then I'm clicking. All right, that's it.
I would like to make a point as kind of we're in that business of creating software for certain patterns. So I think in the big data area we are also in the finding process at the moment. So coming from big data is a lot of data, going towards the real new capabilities you have with big data by looking into the details and understanding the correlations that are hidden deep in the data, and out of that, applications will evolve that can be pre-packaged and provided to customers. But I think there's a whole new discipline that originated from that is this data discovery, where people in the business want to actively look into the data, and we're seeing a lot of new tools coming up with that regard, where you really have new possibilities to interact with the data and understand visually how things behave, correlate, and really interpret that. And that's a completely new paradigm that comes into play with a lot of users who want to actively look into these vast amounts of data.
A very important point, Engel, because when we do look at the applications that people are running, particularly among the enterprise respondents, once we narrow it down to the ISV applications, we do see SAP and SAS getting deployed for these types of solutions. It's just not to the point yet where it's this big dominant ISV vendor share that I guess you're used to thinking of in different markets. This is analyzing the tail of the snake, right? Most of the snake is in the tail, and you get all of these very spread out application types of deployments, which was driving my question about standardization. I really do appreciate your comment there.
I would make one comment on this as well. I mean,
Take the microphone.
okay. If we are looking today, and we agreed before that we are in early adoption state of big data and all the developments. So it's at the end of the day, it turns out in thinking about cost. And in the early stage, maybe there is no alternative in the market. Later on, you don't want to re-engineer the wheel again. So you are looking for alternatives on solutions on the market. And your requirements are that unique that you are hopping on some baselines given from the market and specifying the developments which are already there to move on into your specific requirements. But you don't want to start from scratch again with the whole development.
Great, thank you very much. I do want to hit this content area here before we're out of time, which is directly to the point of big data being an enterprise IT problem that starts to take on some of these characteristics of an HPC problem. And the interesting way to think of this question to me is, to what extent do you think of big data as being part of a standard IT infrastructure versus something special that merits a special investment? Like, that's my regular enterprise IT there. Maybe you'd say, this is my HPC system. Do you want to get people thinking of a subset of their infrastructure as being their big data infrastructure that's different from everything else? No one touching that. Stefan ought to get in there.
Our experience within the last 12 months is pointing directly to that it becomes more and more a thing of traditional IT infrastructure departments. Perhaps they handle it differently from operations of the old traditional enterprise IT approach, what they know since years. But they don't handle it different because it needs different handling. They know they handle it different because they are not experienced with it. But they know that they cannot do it with their tools provided nowadays. So they have to move onto new ground, and they are not secure in moving there. And we see that, and that's what becomes reality when big data problems or HPC solutions approach to enterprise IT environments. That's our experience.
Okay. Bernard, you're looking at me.
Well, no, it's simple. Of course, from Intel's perspective, we're creating the infrastructure, and we would like to see it as an enterprise standard IT, and that's pervasive, cost, price performance is good, so that everybody invests in it. I mean, that's why we're in the game. Just like we made Linux a standard, we're going to make Hadoop a standard.
Do we think there are technologies that we think of as HPC-oriented technologies that start to become enterprise technologies in this context?
Well, isn't Hadoop an HPC approach to data management?
It's a good question, is it?
Well,
Beyond Hadoop, how about things like parallel file systems or InfiniBand interconnects or accelerators? I mean, these are all things that we think of as being HPC technologies. Do they have a role in the broader enterprise space because of big data?
Yes. So we've got solid-state drives and InfiniBand built into the Intel packages.
I mean, for us, that was predominantly driven with the in-memory technology, obviously, because...
In-memory, a good example, by the way, so go ahead.
Because you run into so many topics which are driven by the high-performance computing, the multi-threading, the communication between nodes, massive parallel. You need to make sure you have the correct latencies when you access the memory and everything. So these topics have moved. However, with the help of our colleagues from Intel, that is basically part of modern equipment, and that's the really interesting part that also helped us drive that technology easily to customers. If you buy today a server, it's got 80 cores, and there's a quick path interconnect in there that has an unbelievable bandwidth for the CPUs to talk to each other. And then you have memory directly connected to the CPU, so a lot of the technology that Intel provided there is basically all of this already in the standard enterprise box. And that helps us with customers adopting these new capabilities. Technology is there. I mean, InfiniBand, the storage devices, I mean, the capability to actually get this somewhere. However, what I think will become tricky is a number of concepts that were used in the past will be really tricky going forward. So, I mean, how do you take a backup of 5 petabyte?
Backup restore is a huge part of enterprise storage.
And I mean, this will be interesting questions with the use of big data, how you're dealing with it. So, how is availability managed? So, when is it mission critical for the cluster to be there?